So I am trying to use this Doceri program, which is a writing program that can be projected through my computer and onto the screen. And I use this some in class. But what I wanted to do today is look at an equation and look at the units for that equation. And I guess the way I'm going to write it is thinking about electric field strength, and especially in the lab, the simulation lab, the FET, where the distance between the capacitor plates changed, and that actually affected the electric field strength. Um, so it's the electric field strength is equal to the potential difference uh, or voltage divided by the displacement of a charge in the field, moving parallel to the field. Okay, and so if we think about the units for this, for electric field strength, voltage would be in a measure of energy per charge, which would be, now I'm converting to units instead of using the variables. That is joules per coulomb. And displacement would be in meters. Okay, we can further this with our analysis of units by looking at joules, which is a unit of energy. This is also equivalent to newtons times meters, or newton meters. And so we could write newton meters divided by coulombs divided by meters. Now this simplifies, since the meters will cancel, simplifies to newtons per coulomb, which makes sense because the electric field strength is a measure of force per charge in the electric field. So it's the force that's acting on a charge in an electric field. Sorry about that problem there. Let's see. So I'm going to try to get that back. Okay. Okay, so continuing here. So electric field strength, since it is also the potential difference divided by the displacement, we could also say that's equivalent to units of volts per meter. And that's definitely not intuitively obvious to students, that volts per meter is equal to a force per charge. And so I guess I'm trying to figure some of that out in my head, but as the plates of a capacitor capacitor, where you have a parallel plate capacitor, one plate being the opposite charge of the other plate, if they move together, electric field strength increases, and therefore the voltage would increase because they are proportional. And so and then that would also mean that the force acting on a charge would increase, so that any charge that's moving in an electric field whose strength increases, it would accelerate constantly, but at a higher constant acceleration than if the parallel plate capacitors were spread a larger distance apart. And so I'm interested in sort of simplifying, I guess, the idea of potential difference, electric field strength, and sort of looking at these units, how indeed volts per meter, which describes electric field strength, also could be described as newtons per coulomb, which is I think probably maybe a more typical unit to begin with because of I guess various other equations in which we calculate the electric field strength. For example, we also have the equation electric field strength is equal to the electric force per charge. So the electric force that's acting on a specific charge. So anyway, I find that very interesting, and the reading, I guess, I didn't come across the reading didn't describe this so much, but I am interested, and I think in future weeks we'll probably address more of this material.